Okay, so to do this word problem, I'm going to set section A as x, section B is y, sorry, section A, and the lawn is z. Okay. So total seats is 23,000. So if I add my x, my y, and my z, I get 23,000. It's $75 for each x seat, $55 for each y seat, and $30 for each z seat, and that gives me a total of $870,000. You notice I didn't put my dollar signs in because all that does is kind of clog up the problem, so I don't want to put dollar signs in. Okay. Finally, there's 3 times as many seats in section B as A. So if my A is, my B is y, I need to multiply the section A by 3 to get it equal to y. Since section B has 3 times as many seats as section A, whatever my seats are in section A, I need to multiply that by 3. And these are my 3 equations. Now the bottom equation doesn't have a z in it. So if I can get rid of the z in the top 2, I'm going to be in good shape. Multiply the top by negative 30. So negative 30x minus 30y minus 30z equals negative 690,000. 75x plus 55y plus 30z is 870,000. And use your calculator if you need to. 45x plus 25y, the z's go away, equals 180,000. Now this works out very nicely to get me to a one variable equation. Y equals 3x. So I can plug the 3x in for y. And now I'm at a single variable equation. 45x, 25 plus, times 3x is 75x. And if I add those together, we get 120x. And when I go to my calculator and I divide both sides by 120, my x is 1,500. So that's how many section A seats there are. Section B, I'm simply doing y equals 3 times 1,500. That's 4,500. So now I have my y. And to get my z, I would probably use x plus y plus z equals 23,000. My x is 1,500. My y is 4,500. Plus my z equals 23,000. 6,000 plus z equals 23,000. My z is 17,000. So that's my answer. So I need to establish what my variables are. X is the first number. Y is the second number. Z is the third number. The sum of the 3 numbers is 21. If I add all 3 numbers, I get 21. The second number, which is y, is 2 more than twice the first number. So if I double the first number and add 2, that's my y. The third number is 1 less than the first number. So x minus 1 gives me my third number. My advice here is to get the variables all on one side. So I'm going to change this equation to negative 2x plus y equals 2. And I'm going to change this bottom equation to negative x plus z equals 1, or negative 1, 2. And now I'm going to rewrite my equation. X plus y plus z equals 21. Negative 2x plus y equals 2. Negative x plus z equals negative 1. Now I would either try and get rid of the y or the z. And I would try and do it one of the equations where one of the variables is missing. I would do this. X plus y plus z equals 21. Negative 2x plus y equals 2. I'm going to multiply this bottom equation by a negative 1. And it gives me 2x minus y equals a negative 2. Now watch what happens. X and 2x is 3x. The y's cancel, plus z equals 19. See how there's nothing to combine with the z here? We just bring it down. And now look what I have. 3x plus z equals 19. Negative x plus z equals negative 1. I literally now have that system. Okay? It's actually a little bit easier to get. Multiply the bottom here by negative 1. 3x plus z equals 19. X minus z equals a positive 1. So 4x equals 20. My x equals 5. My x equals 5. Negative 5 plus z equals negative 1. Z equals 4. And 5 plus y plus 4 equals 21. Y plus 9 equals 21. Y equals 12. And those are my three integers. 5, 12, and 4. All three add up to all three add up to 21. The second number is twice more than two more than twice the first number. The first number is 5. 5 times 2 is 10 plus 2 is 12. The third number is 1 less than the first number. The first number is 5. The third number is 4. 5 minus 1 is 4. It should work out on every